Hello there, everyone, and today we should all be on page 53. We're taking a look at solving quadratics, both algebraically and graphically. All right, so for our very first question, we're just going to graph the standard parent function being a quadratic, right? That's our x squared, that's the parent function. And let's just take out our calculators and I'll show you guys how to do this. All right, so we have our calculators out. We have the TI-89. Right now, again, I'm just as a reminder, if I click on this home button or click enter, because it's on home right now, this is just gonna bring you to your standard, adding, subtracting of numbers and things like that up here. Okay, but I wanna graph the function y equals x squared, so I'm gonna hit diamond F1, clear out whatever's in there, and I'm just gonna type x caret squared. Okay, now to graph it, I'm just going to click diamond F3. Now, if your calculator is zoomed into like some kind of funky screen, we're just going to reset that by clicking F2 and scrolling down to where you see zoom standard, which is at number 6. Okay, and I'm going to click enter. Mine was already zoomed in at the appropriate approximations for the screen, like of the width that I wanted it to be. But again, if yours wasn't, that's just how you do it. Now, if you wanted to plot points from the table, we're going to hit the blue button here, second, F5. Oops, sorry, hang on. I hit the wrong one. It's diamond F5, sorry. Diamond F5. And now we're looking at the table of values. All right? All right, so let's start to graph this. And again, just from our table, we would write down the values. Hopefully you don't know, hopefully you do know this off the top of your head. Okay, you're just taking this number and squaring it for each of these. All right, so we've got 1, 4, 9. And again, hopefully we do know what a x squared graph looks like. That's our parabola. So I'm just going to come over and start to graph those points. All right, you guys can finish that up. Okay, and that's what my graph looks like. I'm just going to label the graph f of x equals x squared. Okay, our next question says, what is the domain for this quadratic function? So remember, domain is the x values. So what is the domain? Well, let's see. I'm coming all the way from out here, and I'm continuing all the way to the right. So notice, right, this parabola is continuing, just keeps going, 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 keeps going up, up, up. So we're going out to the left and to the right in both directions. So our domain is from negative infinity to infinity, which is all real numbers. Okay, so now for part C, we want to talk about the range. And now remember, range is our y values. So we want to see, and I'm sorry, I just erased part of my graph here. Okay, for the y values. Well, let's see, what is our lowest y value? Our lowest y value is here, which is at 0. So I include the point at 0. So we have a y value at 0, and we're going all the way up towards infinity. So I'm going from 0 to infinity, where I include 0. There's a point here. And another way we can write this is in set builder notation as y is greater than or equal to 0. All right, let's keep going. Let's take a look at now being on page 54. So let's take a look at the top. All right, so I want to find the table of values for the quadratic function. So again, I'm just going to come over to my calculator and type this into y equals. All right, so here we are back to this applications window, and I want to go to diamond F1. We're going to type in that equation. So I have that x squared. So let's edit this. X squared minus 6x plus 5. Don't forget to click enter. And I want to graph it, so I'm going to go to diamond F3 just to see what the graph looks like. And then again, we're going to write down the table of values by clicking diamond F5. All right, so here are my table of values. I'm going to start at 0 and work my way down to number 6. That's what the table lists for us, so let's do that. Okay, so I just wrote down what our table of values were coming from our calculator here. And to identify where the roots are, guys, remember, if I were to graph, okay, this is just a sketch here, say that was my quadratic function, or I was looking at something like this, okay, where it crosses the x-axis, that's where our roots are. So in both cases, our roots are here. That's when y equals 0. We want to find, say, like, what is x when y equals 0? So if I come over here, f of x is really y. Here is where y is 0, and here is where y is 0. and we have x equals 1 and x equals 5. Okay, so those are my roots. Just doing this from the calculator. If I asked us to algebraically find what the zeros were, well, all right, you have a few options here, algebraically. When I think algebraically, I'm thinking either factor, quad formula, or complete the square, which is everybody's least favorite. So let's see, does this factor? Does anything multiply to -4 but adds to 8? Well, we have -2 times -2. Oops, sorry, +2 is -4. I have -4 times +1. But no, those are never going to get me to +8. So I need to use the quadratic formula. Remember, using the quadratic formula, this needs to be written in ax squared plus bx plus c form, which it is, right? This number out front here is really a. 8 is b. So 8 here is b. And c is our -4. So let's write it out. We have a equals 1. I have b equals 8. And I have c equals -4. We want to fill in this information to the quadratic formula, which hopefully we remember. We have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, and now we're just going to plug in. I always like to put parentheses around everything that I'm inputting the values for. Okay, so we'll have x equals -8 plus or minus the square root. I'm just using this information here, guys. I have 8 squared minus 4 times 1 times -4 all over 2 times 1. Okay, now to type this in the calculator, you should only be putting what's under the radical in the calculator. So watch what I'm going to do here. I'm going to write x equals -8 plus or minus the square root of whatever this is all over 2. So let's put this in the calculator. All right, I've got my calculator here. We are going to, you know what, let me actually move this over a little. Okay, we're going to go to the home screen. So go to the home screen. Do not type the square root. We are just going to do what's underneath the radical. So I have my 8 parentheses squared minus 4 parentheses 1 parentheses negative is down here, 4.
Good morning, everyone.
All right, so this is where I was. We have the negative down here. I hit 4, close the parentheses, and I'm just going to click enter. So now I have inside the radical here, so let me write that. I'm trying to balance this. We have this is now the square root of 80. That's what this value was. Okay, well now we want to simplify this. All right, now to figure out what the square root of 80 is, well, I'm going to go to diamond F1 to get to y equals. I'm going to take the number under the radical, so that was 80, divide it by x squared. Remember to click enter, and I'm going to click diamond F5. So now I'm looking at the table, and I want to see which of these values is simplified completely in simplest radical form. And if I look, I'm just going to circle here, trying to hold my hand steady while holding this. We have 180. All right, we have 220, and we have 5. Okay, the one that is most simplified is 4 radical 5, and that's it. Okay, so now I can rewrite this. We have -8 plus or minus 4 radical 5 all over 2. I'm going to use the heart method. Okay, hopefully you guys remember the heart method or the pretzel method. Whoever you had for algebra 2, doesn't matter, but whatever they called it. Okay, so now I have -8 over 2 is -4. 4 over 2, don't forget the plus or minus, is 2, rad 5. And that is my final answer. Those are the roots for this quadratic equation. So our roots are x equals -4 plus 2 rad 5, and x equals -4 minus 2 radical 5. Okay, so those are my roots for question number 3. Okay, let's just keep going. Let's take a look at question 4. So I have my quadratic function here. So I have my x squared minus 2x minus 8. So now in the other question, we had to use the quadratic formula. Let's see if we can factor. All right, so let's see if we can factor this. What multiplies to negative 8 but is going to add to negative 2? So what's going to multiply to negative 8 but adds to negative 2? Well, let's see. We have 4 times negative 2 is negative 8. But 4 minus 2 is 2, and we want negative 2. So let's go the opposite. Negative 4 times positive 2 is negative 8. And negative 4 plus 2 is negative 2. So these are the two values we're going to use for our factors. So we have x minus 4 times x plus 2 is equal to 0. We're going to t-chart. We'll get x equals 4 and x equals negative 2. So those are my two roots or zeros for this quadratic equation. So I'm at negative 2 and I'm at positive 4 here. All right, so those are my two roots. Again, you guys can also go into the calculator to further graph this. All right, get the table of values and then plot the rest. All right, so this is what my quadratic looks like. The second part, I'm just asking you again, label the zeros so we know our zeros are here at negative 2, 0 and positive 4, 0. And we want to come up with the domain and range. So what's actually kind of neat, guys, and if hopefully you're starting to see this, the domain for any parabola is always all real numbers, where it's going from negative infinity to infinity, which is all real numbers. So that's the set of all real numbers. That's the fancy notation. If I'm talking about the range, remember range is dealing with y. So if I come to my graph here, well, what is my lowest y value? My lowest y value is at negative 9, and all the values are increasing. So if I start at negative 9 and I'm going up, well, we have y is greater than or equal to negative 9, because again, there is a point included here. All right, let's keep going. So let's flip over. We're now on page 55. We're going to graph the following quadratic function. All right, so again, guys, you have a calculator. You can type this into the calculator, but we want to come up with, are these roots rational, irrational, real, imaginary, and then how do we know? So I'm just going to type this into the calculator. All right, so here is my calculator. I'm going to hit diamond F1 to get to the y equals screen, clear out whatever's in there, and then let's just type in the equation. So we have, what is it, negative 2x squared. Okay, hopefully you guys can see this. Minus 4x plus 6. Don't forget to click enter. So there's my equation typed in. All right, hopefully that, yep, there we go, that's clear. And now, if I go to the table, because I want to graph these points, all right, here are my set of here's my table of values. All right, so let's start to just plot the points and graph it. All right, so I just graphed my function, and I want to know, are the roots rational, irrational, and then how would you have known that? So very clearly, guys, look in here. Here are my roots. I'm at negative 3, 0, and I'm at 1, 0. But now, how could you have actually known whether these were real or real, rational, or irrational, imaginary, whatever? We can check. Do you guys remember learning about the discriminant? Okay, I know you're like, it's so long ago. The discriminant. All right, so if we check the discriminant, which is the number that's under the radical of the b squared minus 4ac. So if we just plug in, well, here's a, here's b, and here's c. Okay, so I'm just going to plug in. I have negative 4 squared. It's just negative 4 squared minus 4 times negative 2 times 6. I have 16 plus 8 times 6, which ends up being 16 plus 48, which is 64. Because that's the number that goes under the radical, we would say 64 is a perfect square. So the roots are rational and real. Okay, that's how we determine the roots, the characteristics of the roots, whether it's irrational, irrational, and then real and imaginary. So again, you're just checking with the discriminant. That's the number that's under the square root. Okay, and you're going to see if it's a perfect square, it's rational. If you had something like the square root of negative 4, well, that would be imaginary but also rational, right? Because we would get 2i. So that's rational, but it's imaginary, okay? And again, just filling out the information along with this function. So what's the domain? We already talked about this. It's always all real numbers of a quadratic. We want to find the range, which is our y values. So I'm taking a look. Well, here is my highest y value up at 8, and I include the point at 8, and all of my y values are going towards negative infinity. So we could say we're going from negative infinity to 8, where we include 8. Notice the bracket. Or we could just say y is less than or equal to negative 8. Either one's fine. All right, moving right along. We already said what the zeros or the roots were. We said it was negative 3 and 1. Okay, remember you're writing x equals. Proving algebraically that these are actually the zeros. Guys, you could just do the quadratic formula. I'm not going to do this here. But you can just use the quadratic formula to check that x does indeed equal negative 3 and x does equal 1. The next question says, what is our leading coefficient? Well, if I come back up, all right, well, the degree of this quadratic is 2, which makes sense because it's a quadratic. And the number out front of that x squared is a negative 2. So there is my leading coefficient. And we saw that this parabola was opening down. Opens down. Alrighty. So hopefully we have a nice little overview here. I'll zoom out of question 5 on page 55. All right, and you guys are going to do question 6 on page 56. So this one is for you to try. Question 6 on page 56, and we can compare answers later, but I'm not going to write them all out. Remember, when you're checking to see if the roots are real, rational, irrational, etc., you're checking the discriminant. Okay, discriminant, which is b squared minus 4ac. All right, so you should be using that for this quadratic function. Okay, moving right along, I want to turn to page 57. So page 56 you guys are doing on your own. And let's zoom in here. We're taking a look on page 57, number 1. All right, so let's do that one together. So whenever we're solving quadratics, remember it always has that x squared, or in this case we're using the variable a. Okay, doesn't matter though. We always want to make sure that we set the equation equal to 0. We can either factor, and if it's not factorable, then we have to use the quadratic formula. Okay, we also want to make sure it's in the correct form of ax squared plus bx plus c equaling 0. Right, where a is your leading coefficient, b is one of our coefficients, and then c is the constant. All right, so let's see here for question 1. So already I can see it's not equal to 0. So I'm going to subtract that 6a on both sides. There are no like terms here, so I'm just going to write it out as a trinomial. And now we can start to either see if we can factor or use the quadratic formula. Okay, so if you want to factor, go for it, but I'm just going to use the quadratic formula, again, just to reiterate how it works. So now we have a equals, we have negative b. So here's b. Let me write it out first. How about I do this? A is equal to 1. B is equal to negative 6. C is equal to negative 16. Okay, so now, yeah, maybe I should write out each piece first. So we'll have A equals, we have negative B. So here's negative B, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So now I have A equals 6 plus or minus. Remember, this whole thing underneath the radical goes in the calculator. Okay, not the radical, what's underneath it. And you should end up getting 100 all over 2. Well, this is nice. I know what the square root of 100 is. Square root of 100 is 10. So I have A equals 6 plus or minus 10 over 2. All right, we can start to simplify this using that heart method. I'll have A equals 6 divided by 2 is 3, plus or minus 10 divided by 2 is 5. And now let's split our terms. We have one with 3 plus 5, the other one with 3 minus 5. A equals 8, and A equals negative 2. So granted, you could have factored this, but I just wanted to show you how to do this with the quadratic formula. All right, so I would like you guys to do question 2. Again, I'll just write what the final answer is, but you need to provide the work. Your final answer here should be x equals -2 plus or minus the square root of 3. But you need to do question 2 on your own. Okay, let's keep going. Let's do question 3 together. Question numero 3. All right, so again, I'm always going to write out what is my A value, what's my B value, and what's my C value. Be careful, right? Sometimes we forget to include that negative, so don't forget it. Okay, I'm going to write out my formula for the quadratic formula. We have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, I'm not going to sing that every time. All right, so now we're just going to plug in. We have x equals, we have -6 plus or minus the square root of -6 squared minus 4 times a times c all over 2 times 3. All right, again, we should be putting what's underneath the radical into the calculator. So I'll demonstrate that again if we need it. All right, so here I'm in my home screen, clear out whatever's in there. We have parentheses -6 squared. Okay, I have, I hit the parentheses wrong. Hang on, let me fix that. Delete, I was meant to do this kind of parentheses, there we go. Minus 4 times 3 times 4, enter. And I got negative, here, can you guys see that? -12. All right, so my answer here, wow, this is terrible, is -12. That's what's underneath the radical. So let's rewrite this. We have x equals 6. That's really 6 plus or minus the square root of -12, because this is -12 all over 6. All right, well, you should be noticing that you have a negative under your radical. My answer is going to be imaginary. So let's break down the square root of -12. Well, we know one of them is going to be rad 12, the other one's -1, which we all know the square root of -1 is I. Yes, we do all know that. Okay, we're going to break up the square root of 12 to being rad 4, rad 3. So we have 2 radical 3i. So that's what we're going to replace this whole thing with. So now I have x equals 6 plus or minus 2 rad 3i all over 6. And again, we can use our pretzel method, heart method, whatever you prefer. 6 over 6 is 1. 2 over 6 is a third, and we leave the radical 3i. All right, guys, so that is your final answer. You also could have written it like this if you wanted to. 3 plus or minus the square root of 3i all over 3. That would have also been acceptable. Okay, so again, because we had that negative underneath the square root, it's going to be imaginary, and then we just followed simplifying radicals to continue. Okay? All right, you guys are going to try question 4. Your answer here is just -10. But again, you need to show the work. So answer for question 4 is -10, but you have to show the work. All right, so I am skipping over to page 59. I would like for us to do question 3 together, and you guys are going to do question 4 on your own. So question 3 we're going to do together. 4 you're going to do on your own. All right, so for question 3, well, it says solve for this algebraically, graphically, so let's just plug this into the calculator. All right, so here's my calculator. I'm going to diamond F1, get back to y equals. I'm going to type in x squared minus 20, click enter, and I want the table of values. So let's go to diamond F5, and here are my table of values. All right, so we're going to plot points that we actually can graph. When I actually did create my graph, guys, I ended up going by 2s. So I went by 2s here. Okay, so I'm just going to graph the points so far that I see on the side here. All right, so now that I've graphed my quadratic function, well, the question says find the roots and the zeros. Now, well, I have that it crosses somewhere over here and over here, but I don't know exactly what that value is. So guys, we actually need to solve this algebraically. When we solve quadratics algebraically, remember we set it equal to 0. Okay. All right, let's maybe add the 20 to both sides. So now I have x squared equals 20. Remember, to get something that's squared, we square root. So we square root. I don't really need to write that 2 there. That's implied. Okay, so now I have x equals. Remember, when you square root both sides, we need a plus and minus. The square root of 20, okay, well, we can simplify that into square root of 4 and square root of 5. The square root of 4 is 2, and the 5 comes along. So my final answer here, guys, is plus or minus 2 radical 5. So this point here is negative 2 rad 5 for x, and this one here is positive 2 radical 5. So those are actually my solutions, okay? I want you guys to try question 4. Again, question 4 on page 59. I'll write what the final answer is, but you guys need to show the work. Your final answer is 5 plus or minus 2 radical 3. Show your work. Make sure you get the same result as me. Again, if you get something different, there's a chance I made a mistake, so let me know. Okay, and the last problem that I want us to take a look at is on page 60. I love this question. I know we have different passions, maybe. I don't know. Okay, so for question 5, we have the profit of a coat manufacturer. All right, maybe it's Burlington Coat Factory, but whatever. All right, so we have, this is the model for the quadratic function where P is the profit. So we have P represents the profit and X represents the price for each coat. Okay, we want to know for what values of X does the company make a profit? So we don't have to use the graph, that is optional, but let's see. For what values of X does the company make a profit? All right, well, I've got a quadratic function, right? So I have P of X equals negative X squared plus 120X minus 2,000. And we want to solve for X. So let's do it. Let's solve for X, right? If this thing equals 0, okay, if the profit equals 0, we've made no money. But I want to actually show a profit. So really, we're going to be looking for this thing to be bigger than 0. For right now, let's just solve for the roots, and then you'll see what I'm talking about if that didn't make sense. All right, so first, let's just solve for the roots. So we have negative X squared plus the 120X minus 2,000. I'm going to use the quadratic formula. I've got X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. I've got A equals, right, this is a negative 1 out front. B equals 120. And C equals this negative 2,000. All right, again, we're just subbing into the formula. We have X equals negative. I always like to write it out like this. Okay, put all my parentheses. You get used to it after doing it for a while. All right, so in here should be negative, then parentheses B, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. I'm going to put this in my calculator, right, because I don't want to do that in my head. That one's kind of long. And we have X equals negative 120 plus or minus the square root. So when I put this in the calculator, I get 6,400 all over negative 2. All right. Square root of 6,400. Does anyone actually know what that is? There's an easy way to do it. Think about the square root of 64. Well, the square root of 64 is 8. So square root of 6,400 is actually 80. All right, so we have plus or minus 80 all over, right? We just got that extra 0 here. So we have the square root of 6,400 is 80. We have this is all over negative 2. And again, I'm going to use my heart method. X equals negative 120 over negative 2 is positive 60. Plus or minus, guys, it doesn't matter what this is here because it's plus and minus anyway. So 80 over 2 is 40. All right, we're going to break this up. We have x equals 60 plus 40 and x equals 60 minus 40 because of this plus or minus here, right? One gets the plus, the other one gets the minus. And we're left with x equals 100 and x equals 20. Now, that's when, if we go back to the very beginning, that's when we said if x equals either one of those values, we make no profit. But I want to make a profit. So I want to make a profit. So, okay, well, let me just write out our equation one more time. We had p of x equals negative x squared plus 120x minus 2,000. So we want this thing to be greater than 0. We want it to be bigger than 0. Okay. Well, if it equals 100, there's no profit. And if it equals 20, there's no profit. So we need to be between 20 and 100. Because if the number is 30, yeah, that's going to make a profit. If it's 100, no, I make no profit. Because remember, we just said we solve for the roots. When x equals 100, y equals 0. There's no profit. So we need to be between 20 and 100. This is kind of a domain question, and I'll show you guys really quickly, too, how to do this on the calculator if you choose to. All right, so I'm doing this here with you. So our equation, let me make room here so I can see what our equation is. Our equation is negative x squared plus 120x minus 2,000. All right, so let's just make sure I wrote that correctly. Negative x squared plus 120x minus 2,000. Remember to click enter. And let's graph it. Diamond F3. Now, 100% we know that this is not going to fit on the screen. We already know that because we found that, here, let me highlight here. We already found that x has to be between 200 and 100. So let's adjust our window. So if I go to Diamond F2, let's make x min, I don't know, 0, right? Because x deals with money. So let's make that 0. And let's make x max 100. Okay. If I go to Diamond F3 to now graph this, all right, now I'm missing the top part of the parabola. So let's fix that. Okay, all right, now can you guys see that it actually goes over here on the end right here? So maybe I'll even extend my window even more. Maybe we'll go to 120, just so you see a little bit more of the graph. And let's make y max, I don't know, let's make it go to 100. And don't forget to click enter. Let's try to go back and graph it. So even 100 wasn't enough. And a way that you can check this, guys, is let's go to the table. What are the y values looking like? What do our y values look like? All right, we want to get out of the negatives because, again, we want to make a profit. Oh, we're going up pretty high. So let's try to bring it up to, I don't know, 5,000? Sure. Let's change our window for our y max. Let's go up to, like, I don't know, 3,000, 5,000. Sure. Now when we go back to graph, hopefully, there we go. Now I see what the graph looks like. All right. And again, we can see this is where we're making a profit. So we're between that 20 and 100 where we're making a profit. These are the profit sales, okay? Because we said, and I'm actually bringing this back over to my paper here, where we're modeled by this equation. P is the profit and X is the price for each coat sold. So there you guys have it. We're between 20 and 100. All right there, everyone. I hope we found this video helpful. Again, going over all of the different ways that we can solve quadratics using the calculator, algebraically. All right, so stay tuned for your next lesson.